Okay, so I tried a different model for the soil problem, and what I had was on the explanatory axis, so the x-axis, I had my velocity in kilometers per hour, and on my y-axis I had the logarithm of erosion. Okay, I don't have enough room there, but that's erosion there. And remember, erosion was in kilograms per day. So the logarithm of kilograms per day is what I had. Don't like how I spelt that. And that's the logarithm of erosion there. Okay, and you know, it's pretty straight. So I think a line seems like an appropriate linear model. And then I looked at my R value. Well, that was better than the 0.9 that I had on the other with the original data. So I'm feeling good about that. And then I looked at the residual plot. And remember, the residual plot has your velocity here, and on here is your errors. But this is the errors in the log of erosion. Okay, I'm not going to write that in. Okay, and I've got a concern. Maybe it's not that pronounced, maybe I can get away with it, but it seems like in lower speeds I have bigger errors than when I have higher speeds. I have smaller errors in my model. So that cone or that tapering is a bit of a concern. Now, it may or may not be that I can still use this model, but I'm going to have some concerns, so I'm going to check some other models out. Okay, so I'm going to show you some other models here in a second. Okay, so here's a model, and what I did was I decided that, so you can get an idea of things, that point is right there. Okay, so that I'm going to leave it circled, but that point is x. Now, what does x mean? It's actually here. It's the logarithm of velocity, so it's the logarithm of kilometers per hour. And just like the other one before, this is the log of erosion, which is measuring in kilograms per day. Okay, so what I'm going to do is I'm going to get rid of that there. Okay, and just so you know that that coordinate gives you an idea where the numbers are at. And if I change the color here for a second, I can see it doesn't look much different than the other model. It's not that, and it doesn't have that much different R value, so we're feeling pretty good. But I still have, so again, here's your, sorry, I'll change the color. So we saw a pretty good correlation. The model, though, has a similar problem. When I did log, the residual plot here, okay, basically has that same tapering effect. And so model isn't really going to be useful here. If it was the model, you would have log of the predicted erosion, I'm just going to call it eros, equals, if this were the model, 4.5, with logs you want to go more decimal places, 4.579 times, that's the slope, times we're talking about velocity, and then we're going to subtract 4.0743. That would be the model. It has a good R value, but I've got this, again, same thing. Big errors with small x's, small errors with big x's, and that pattern seems to hold here, so I have a concern with the log model. Those are usually your first two bets to use. Is start with the log of y, then try the log of y and x. Okay, so we'll go on to another model in a second here. Okay, the other model that you usually try when you try the logs, we did the normal x of our data at log y. We then tried log x, log y, and the other one you can try a lot of times is log x, normal y. But when I didn't do that third one because it's also going to give us the same problem. So I just wanted to speed things up. When those three fail, then you really need to do something like a reciprocal of y or a reciprocal of x. Or you can do square roots. And I tried this. This is the square root model. So when I look at this, I have normal x, which is velocity. I have erosion here, but I have the square root of erosion. Same units as we talked about before, and that's on the y-axis, right? Whoops. That's on the y-axis right here. Okay? And again, for reference point, I put a point here so you know that the velocity is 19 kilometers per hour. And this would be, and the y would be this, it would be the square root. Whoops. We're dealing with the square root of y is that. Okay? So that's what we're looking at there. And when I draw it, looks like a line seems to fit the data. We get a little bit better R value, although that's not always a guarantee. And so if we look at our model, what we're saying is the square root of the predicted erosion is the slope 0.994 velocity minus 10.32. Okay, so that's what we're getting there. And if I look at the residual plot right here, remember errors are along the y-axis. This is still velocity. It seems fairly random. Some people might make the case it's kind of going down and up, but it's fairly random. I have some points above and below here. I have some points, a point above, one on, and then some points below. And I've got some points above, one on, and below. It's not too bad. Okay, so I think this is probably our best model. If we're going to make a prediction on it, this would be the best model. So I'm going to go to the next page. I'm going to rewrite the model again. I'm going to go to the next page. So I'm going to rewrite this on the next page, and we'll go ahead and make our prediction. So it's the square root. Okay. And if I go back, it said 0.994. 0.994 times the velocity minus 10.32 it was. Yes, 10.32. Okay, and so they're asking us to make a prediction. So they're asking us to make a prediction when V is 24 kilometers per hour. So I'm going to get the square root of the erosion equals 0.994 times 24 minus 10.32. So I put that in there, and I get the square root of the predicted erosion is 13.536. I'm going to have to square everything to get, because I want the erosion, not the square root of erosion. And when I do that, I get the predicted erosion is, I'm just going to put that in the calculator here. It seems too high. Yeah, it seems too high, but when I go back and look at the data, it's definitely between at that speed. That actually can move quite a bit of soil, quite a bit of topsoil at that speed. 24 kilometers an hour is pretty fast speed for wind to come at. So it makes sense. It's given the data, it's definitely in there, in where the data said for there. So I think we're in okay shape.